students, and welcome to today's session. Today we'll be discussing chapter 1, matter in our surroundings. So let's quickly start with the session. Firstly, we'll be talking about the physical nature of matter. Kya hai matter? Everything around us is made up of matter, right? But what is matter composed of? What is matter made up of? Matter is made up of particles, and these particles are very small, so small that they may not be visible to the naked eye, right? So matter is made up of very small particles, and particles of matter, they have space present in between them, right? If you take water, if you put a little bit of potassium permanganate in it, the water will turn pinkish purplish in color, right? So that means that the particles of potassium permanganate have actually gone into the spaces that are present between the particles of water, and that is how the change in color is seen, right? Next, particles of matter, they are continuously moving. They possess kinetic energy, right? Particles of matter possess kinetic energy. And as the temperature rises, this kinetic energy also increases. With increase in temperature, the kinetic energy of the particle increases, because of which the particles will move faster. Kinetic energy बढ़ेगी particles की, तो वो ज़्यादा जल्दी fast way में move कर पाएंगे. Particles of matter, they can intermix with each other on their own, जैसे कि हमने discuss किया था, by getting into the spaces that is present between the particles, they can intermix on their own. And this intermixing of two different types of matters on their own is known as diffusion. And if we heat a particular substance, on heating, the diffusion will also become faster. That is why it is easier to smell hot food from a distance as compared to cold food, right? And particles of matter, they attract each other. Now, there are three states of matter that we are going to talk about: solid state, liquid state, and gaseous state. Solids, they have a definite shape, they have a fixed shape, they have distinct boundaries, fixed volumes, and negligible compressibility. It is not very easy to compress a solid. Solids have a tendency to maintain their shape. Even if you apply force on them, even if they are subjected to force, they have a tendency to maintain their shape. They may break if excessive force is applied, but it is difficult to change their shape. So we can say that solids are rigid structures. They do not change their shapes very easily. If we take the example of a rubber band, if we stretch a rubber band, for that moment that we are stretching it, it might change its shape, but as soon as we release the force, we stop putting any force on it, it will come back to its original size. It may break if excessive force is applied, but it is difficult to change the shape of a solid. Next state of matter is liquid state. Liquids do not have a fixed shape. They will take up the shape of the container in which they are kept, but they do have a fixed volume, right? Liquids, they can flow. They can change their shape while flowing. So we say that liquids are not rigids. They come under the category of fluid or fluidic substance, right? We see that the aquatic animals that are present, they are able to breathe underwater because oxygen is dissolved in that water. That is how they get oxygen. They take up dissolved oxygen present in water. So solid, liquids, and gases, they can easily diffuse into liquids. And the rate of diffusion obviously will be higher in liquids as compared to solids. If we talk about the gaseous state, gases are highly compressible as compared to solids and liquids. LPG cylinder, or the oxygen which is supplied to hospitals, it is actually present as compressed gas. And CNG, which is used as a fuel in vehicle, which is a good substitute for petrol and diesel, because of its high compressibility, because it is so compressible, large volumes of that gas can be compressed into a small cylinder and it can be transported easily, right? Gases, the particles of gases, they move at very high speeds, and there is a lot of space present between the particles of gases. They show the property of diffusing very, very nicely. Gases, they can diffuse very fast into other gases. So if we look at the state of matter, we see that the particles of solids, they are tightly packed together with less space in between them. Then we see liquids, the particles of liquids are fairly loosely packed and they can move around because there is space present between the particles. And gases, they are very loosely packed. The particles of gases are very loosely packed, and that is why they can move around easily. If we check the compressibility, gas is very compressible. Then comes liquid, and solid is the least compressible of the following. So solid is a very rigid structure. Liquid is somewhat less rigid, and gas is the least rigid, right? Now, change in state of matter. How can we change the state of matter? For example, ice is solid, water is liquid, and water vapor is gaseous. So how can we actually convert ice to water and then water to water vapor, right? So the minimum temperature at which a solid will melt to become a liquid at atmospheric pressure is known as its melting point. The melting point of the solid indicates the strength of the force of attraction. कितना ज्यादा force of attraction है? ज्यादा force of attraction है, melt करने में ज्यादा time, ज्यादा melting point होगा, right? So melting point of a solid actually indicates the strength of the force of attraction between its particles. The melting point of ice is approximately 273 Kelvin, right? And this process of melting in which solid state changes into liquid state is also known as fusion. Okay, the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So the particles in water at 0 degrees Celsius, they are going to have more energy as compared to the particles in ice at the same temperature. Particles of water will have more energy as compared to the particles in ice at the same temperature. Now to convert liquid to vapor form, अभी solid से liquid melting से किया, liquid से vapor होगा by the process of boiling. So the temperature at which the liquid will start boiling at atmospheric pressure is known as its boiling point. And it is a bulk phenomena. The liquid needs to gain enough energy, and when it gains enough energy, it can actually change into its vapor state, right? For water, this temperature is 100 degrees Celsius, which is roughly about 373 Kelvin. And again, the same principle will apply, that the particles in water vapor at 100 degrees Celsius will have more energy than water at the same temperature, and this will happen because of the latent heat of vaporization. So latent heat of vaporization and latent heat of fusion. Now, what will happen if pressure is changed? What is the effect of change of pressure? By applying pressure, we actually bring the particles of matter close, right? The distance between them decreases, the differences in the distance decreases, and the particles can actually come closer. So by increasing or decreasing pressure as well, we can change state of matter. प्रेशर को इंक्रीज या डिक्रीज करके भी चेंज कर सकते हैं हम स्टेट ऑफ मैटर, बिकॉज particles can be brought closer together if pressure is applied. So applying pressure as well as reducing temperature at the same time can actually liquefy gases, right? This is the interconversion of state of matter: solid to liquid, fusion, liquid to solid, solidification, solid to gas, sublimation, gas to solid, sublimation, liquid to gas, vaporization, and gas to liquid, condensation. Next, evaporation. Evaporation is a phenomena in which liquid changes into vapors at any temperature which is below its boiling point. लिक्विड से वेपर में बॉइलिंग में भी चेंज हो रहा है, बट एक स्पेसिफिक पॉइंट पे, एक स्पेसिफिक टेम्परेचर पे, जिसको हम बॉइलिंग पॉइंट बोल रहे हैं. बट इफ दिस चेंज हैपेंस एट एनी टेम्परेचर व्हिच इज बिलो द बॉइलिंग पॉइंट, दैट इज नोन एज evaporation, right? Why does evaporation take place? Because in a liquid, the particles that are present at the surface of the liquid, right? A small fraction of particles that are present at the surface of the liquid, they have higher kinetic energy. Unki kinetic energy zyada hai, so they are easily able to break away from the forces of attraction of other particles, and they are easily, able to be converted into vapor form. Now, there are certain factors that affect evaporation. The rate of evaporation increases with increase in surface area, because evaporation is a surface phenomena. Surface area increase hoga, zyada area hoga for the particles to evaporate, and the rate of evaporation will increase. That is why when we put clothes for drying up after we wash them, we evenly spread them out so that they dry faster. Next, rate of evaporation increases with increase in temperature. Obviously, with increase in temperature, we have discussed that the kinetic energy of the particles increases with increase in temperature. So when the temperature is increased, more particles will get kinetic energy to go into the vapor state. The rate of evaporation increases with decrease in humidity, because humidity means how much moisture is present in the air around us, and the air around us, it also has a saturation point. It cannot hold more than a specific amount of water vapor at a given temperature, and if already water vapor and moisture is present, then obviously the rate of evaporation is going to decrease. If the amount of water in the air is already high, then the rate of evaporation is going to decrease. And lastly, rate of evaporation increases with increase in wind speed. So when there is an increase in wind speed, the particles of water vapor, they can easily move away with the wind, and they can decrease the water vapor present in that particular surrounding. So the rate of evaporation increases with the increase in wind speed, right? So evaporation causes cooling. Evaporation is associated with this cooling effect, which we see when we put acetone on our palm. We see that the palm feels cold, right? On a sunny day, we sprinkle water on the roof or the garden for that cooling effect. So evaporation is associated with the cooling effect. During summer, we perspire more, because this is a mechanism used by our body to keep us cool. And during evaporation, what happens? The particles that are present at the surface of the liquid, we have discussed the particles present at the surface of the liquid, they gain energy from the surroundings to break free from other particles, from the force of attraction of other particles, and get converted into vapor form, right? So this heat energy is equal to the latent heat of vaporization, and it is absorbed from the body, which gives the body the sensation of feeling cool, right? And cotton, being a good absorber of water, helps in absorbing sweat and exposing it to the atmosphere for easy evaporation. That is why it is recommended to wear cotton clothes in summer. When we take ice water in a tumbler, we see that water droplets are present on the outer surface of the tumbler. This happens because of condensation, because the water vapor which is present in the air, it will come in contact with this cold glass of water. It loses its energy and it gets converted into liquid state, which we see in the form of these tiny water droplets. So what is actually happening is that the water vapor which is present in the air, when it comes in contact with this cold glass, it will lose its energy, and because of which it gets converted into its liquid state, which we see in the form of these water droplets, right? So that is all for this session, and I will see you all in the next session.